All right, so quick talk here about conversion factors. A conversion factor is, well, it's the number one. And it's the number one because we're going to multiply by it, and we don't want to change the thing that we are multiplying. So a classic example of a conversion factor is something that you use to deal with a fraction that's not in lowest terms. Like if I have 6/8, then I can use a conversion factor, like 2/2, and end up with 3/4, putting the fraction into lowest terms. This thing here is my conversion factor. Key things to recognize about this conversion factor: A is equal to 1. Top and the bottom of the fraction are the same. And B, we multiply or divide by it. And since it's equal to 1, C, that doesn't change what we're dealing with. So why would we ever use conversion factors? Well, generally speaking, we use them when something is in one form that we don't like a fraction not in lowest terms, and we want to change it to something in a form that we do like, a fraction in lowest terms. So that's the general theory here behind using these conversion factors. Now, the ones that we use in chemistry are going to be slightly more common. So conversion factors in chem. Let's go back to an equality that we established on the first day of the year. We said that 1 dozen as a unit of measurement was the same thing as a count of 12. Which means that I can write two different conversion factors. I can write this conversion factor, 1 dozen over 12. And I can write this conversion factor, 12 over 1 dozen. Notice that both of these things are just equal to 1, right? A dozen divided by 12, 12 divided by 12 is 1. 12 divided by a dozen is 1. So if I multiply by these two factors, if I divide by these factors, nothing is going to change. I'm going to get the same amount that I started with. So why would I use these? Well, let's say I had a situation where I had a number, like say 54, and I wanted to rewrite that number as some amount of dozens. The trick here is that I can use this first conversion factor, the blue one, to make this happen. I can multiply by 1 dozen over 12. And since I'm multiplying by 1, I'm not going to change anything, but I am going to get an answer in dozens. If I do 54 times 1 divided by 12, well, I get 4.5. And so my conversion gets me to 4.5 dozen. In other words, 54 cakes is 4.5 dozen cakes. And we can do this in the other direction as well. Let's say I had something like 6.5 dozen. And I wanted to translate that into a count without the dozen in. So if I have 6.5 dozen cakes and I want to translate it to a count of cakes, I can use a conversion factor. Specifically, I can use that second conversion factor. I can multiply by 12 over 1 dozen. Now when I do that, I do the math. I do 6.5 times 12, and I get 78. And then since I multiply by a dozen and divided by a dozen, my dozens cancel out. And I'm left with just 78 cakes. So by using a conversion factor here, I could go back and forth from a number of dozens of cakes to a count of cakes. You might say, okay, this seems like a really complicated way to do something that's pretty darn straightforward. But when we have multiple different unit systems to convert between, these sorts of conversion factors can be really, really useful. So let's say, for example, I had a question like this. What is the mass of 1.2 times 10 to the 24 lithium atoms? Okay, there are two important conversion factors that I'm going to use here to deal with this. The first one is a conversion factor between count and moles. So I'm going to write a conversion factor, which is that there is 1 mole for every 6.02 times 10 to the 23 count. Notice that this is equal to 1 because the top and the bottom are the same. 1 mole is the same thing as 6.02 times 10 to the 23. And my other conversion factor, okay, we'll do in blue, is going to be that there are 6.97 grams of lithium if I have a mole of lithium. This is stuff that we did in class today. We said if we want to find the mass of a mole of lithium, I can look on the periodic table and find that it's 6.97 grams. So now, armed with these two conversion factors, I can actually answer my question. I have 1.20 times 10 to the 24 lithium atoms. I want a final answer that's telling me about some amount of grams of lithium. So if I multiply by the purple conversion factor, 1 mole, sorry, I should have atoms here, for every 6.02 times 10 to the 23 atoms. And then I multiply by the blue conversion factor, 6.97 grams for every mole of lithium. Then, my units cancel nicely. Atoms cancels atoms, moles cancels moles. The only unit I'm left with is grams, and the unit I want to finish with is grams. So that worked out. Then my math is to do 1.20 times 10 to the 24 times 1 divided by 6.02 times 10 to the 23 times 6.97. And off the top of my head, if I do that, I get 13.94. So by using conversion factors, I was able to set myself up to properly go between a measurement of a number of atoms, a measurement in moles, and a measurement in grams. And this is critical to us getting work done in chemistry. So tomorrow, we're going to do a bunch of these sorts of conversions. And while you don't have to use these conversion factors to do so, practicing this skill and getting good at it is going to make it super, super easy to do these kinds of conversions in the future. All right, thanks for watching.